This is the first video of a series of videos where we're going to talk about how to find the area of a regular polygon. This is for Unit 8, which is area of our geometry class. We're in the 5th day of material right now. So this is video 1 that we're getting ready to start. Before we begin, remember, a regular polygon. The word regular means something in this class in geometry. It means not only is it equiangular, all angles are the same, but it's equilateral, which means all sides are the same. So when you look at these two diagrams, you'll notice that this one obviously is not a regular polygon, whereas this one is. So we know it's 1, 2, 3, 4, 5 sides. We know each of the 5 sides is the same. And if we did the n-2 rule, we would find out that these angles add up to 540. That makes each of them 108 degrees. So there's a lot of information that we know about this regular polygon right here. The question is, can we find the area? In order to find the area of a regular polygon, we really need 3 dimensions. We need to know, first of all, how many sides. We call that n, is the number of sides. So in this case, the picture that you see here, n would be 5 because it's a pentagon, 5 sides. We need to know, and we use s to represent this, we need to know what the length of each side is. It would be helpful to know whether it's 5 inches from here to here where my fingers are, or 10 inches or 20 inches, because we can see that the bigger the side, hey, the more area it's going to cover, right? And the last thing that we have that's going to help us out is going to be what's called, it's R, and it's going to be confusing, but it's called the apothem. And notice how I said that, apothem. So you stress the A, it's not a possum, okay? That sounds like you're saying possum, okay, like a dead animal. It's apothem. The apothem I will explain in just a second. Those are the 3 dimensions that we want to be able to find. So n would be the number of sides, s would be the distance from here to here. I guess I'll just go ahead and draw it in the document. R is going to be this dotted line that I can draw from the center of the polygon down to the middle of one of the sides. Notice it meets at a right angle. So, with that being said, apothem, there's a couple things I want to stress here. It's a line that was drawn from the center to one of the sides. But the kicker is this. It's never going to go to a corner of the polygon. It's always going to intersect the middle of a side at a right angle. So when you draw, and what they're going to do in the problems, one of the things that's going to be confusing to you is they will give you this sometimes, and other times they might give you this dimension instead. They might draw a line that goes from here to here. And this is not the apothem. Okay? There's a different name for that. Notice how it goes to a corner. So whenever we draw the apothem, the key for doing polygons hinges on finding that length right there, the apothem length. That's the one thing that you're going to struggle with while you're doing these problems. Now, let's talk about how to find the area of a shape, and let's do it the long way, because there is a long way, and this is a way that some people prefer. I could do this. Let me get a ruler real quick. I could do this. I could say, look, you know, if I just do this and split this up into a bunch of triangles by drawing a line from the corner all the way down here, I would notice that I have a bunch of small right triangles, don't I? And furthermore, every single one of these right triangles, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Makes sense. I have a pentagon, which is 5 sides, and each one of those sides has 2 little right triangles. Okay. I know that also that the area of all of those triangles is the same. So if I could figure out a way to find the area of one of these triangles, all I have to do is multiply it by 10. Why 10? Because it's a pentagon and there are 10 triangles on a pentagon, twice as many as there are sides. Well, finding the area of a triangle involves finding the base and finding the height. Well, that's easy. The height here is 8. And the base is not 10. The base is not 10. The base is half of that, which is 5. So if I wanted to find the area of that triangle, I would say base times height is 8 times 5, that's 40. It's 1/2 base times height, so really the area of that triangle is 20. Seems pretty simple, right? Now what do I do with that 20? I have 10 triangles that are exactly like it, so I take 20 times 10 for the 10 triangles. That's a square, that's 200 square units. And that's fine. You could do that, but you're going to find out that this problem gets a lot more complicated in a hurry. See, I gave you a lot of the information that you actually needed in order to solve this. But there is a faster way. The shortcut is this. The area of a regular polygon can be found using the following formula. 1/2 NSR. You know the 3 dimensions I told you needed? The number of sides, the length of each side, and the apothem length. If I plug those into this formula, I'm going to get it in one step. I will show you a couple of variations on this formula. If you go online and you look, you do a Google search for area of a polygon, you're going to see 50 different versions of this exact formula. But if you can remember 1/2 of NSR, then you're going to be good. So I could have done just 1/2. The number of sides, well, that's a pentagon, so n is going to be 5. Each side length is 10 units in length, so that's 10. And the apothem length from the center down to a right angle, notice it's not to a corner, is 8. And if I multiplied these all together, I would have gotten, let's see, 5 times 8 is 40. 40 times 10 is 400. Half of that would be 200 square units, right? So there is a shortcut. Let me show you what the shortcut is. Let me show you another variation of this formula if you happen to go Google it. If I took 10, the length of each side, times 5, because you have 5 sides, 10 times 5, this part right here, which is really the n times the s, that's really the perimeter of the shape. So you will also see it written as 1/2 times the apothem length times the perimeter length. And you're going to see variations on that, and that might be helpful. I mean, I really don't care. You just need to find a way. Once again, it comes down to maybe making flashcards or something. But you need to find a way to memorize this formula so you can use it, so you don't have to do the right triangle method all the time. That's going to take you a lot longer, and you'll see when I get to the complicated examples in the next video why that's so difficult. Okay, so that's it for video 1. In the next video, I'm just going to be working through some example problems, and they're going to get harder in a hurry.